Computing as a paradigm has become so basic in our world that I think people should learn it. It should be part of our schools, just like math and languages are, because it's just so well integrated in our it's like our world now depends on computation, and I think more people understand how computation functions, the less they will be fearful of it, and the more they can ask like really hard questions, right? Like, so I think it's people should definitely use these tools to teach themselves the challenges of programming and learn that. I think that's a really beautiful thing. And I love that these large models have made coding so accessible.
Thank you for joining Once Changing the World. I'm your host, Eddie Avil, and today I'm delighted on to have with me Shivali Mohan Ashok, an AI scientist. She's ex Xerox, PARC, and currently AI consultant at Toyota Research Institute. She has worked with various US government agencies, including DARPA, ARPA-E, and NIL, and is known for her work on intelligent agents, human AI collaboration, Neuro-Symbolic architectures with a focus on designing resilient, adaptable, and human-aware systems for domains like healthcare, robotics, and sustainability. So, Shivali, really appreciate you taking time being part of the podcast. Uh, Wanted to do an episode on AI agents, and so obviously this episode we're gonna talk largely about AI agents. That's your expertise. So it'll be great if you could start with maybe explaining what AI agents are.
Yeah. So thank you, Eddie, for having me. It's really wonderful to be at a podcast that's hosted in India and focuses on the current frontiers of technology. As you said, I've been building agents for 15 years since I started research in graduate school. In the simplest way, you can think of agents as computational machines that are sensing their environment. So this is when I look like you can. Humans are the best analogy to think of agents because agents are now being designed to emulate and simulate human decision making. So you sense your world through your eyes, through your ears, through your touch, and you form an internal model or a representation of the world that you exist in. Now, you may have certain drives, certain goals that you want to achieve. And given those drives and goals and your understanding of the world, you make a decision, which is to what next action to take. Then you go ahead and take that action. This would be through your what would be called effectors. So this would be your arms, your legs, and other ways you manipulate the world. And as you manipulate the world changes or shifts a little. And then you engage in this loop again, and you keep on doing it unless you reach the goal. Like for humans, you can do it at a very basic physical level where you are like moving objects around, but also at a very higher level when you are pursuing, studies and you are trying to learn something. It's the same process. It's just happening on different inputs and outputs. So agents, you can think of it from the same framework. We are trying to build computational machines that can sense the world, make a decision given certain goals and drives they have, and select an action and apply that action to the world and continue to doing this loop until it reaches some goal. So that's like the most basic definition of an agent.
Right. Shivali, I appreciate you kind of, explaining it so beautifully. Now, I was on your LinkedIn page and I saw this article that you had written titled The Age of Agents last year, where you kind of describe the level 0 to level 4 plus agents. So will be great if you kind of maybe explain us and run the audience through that level 0 agent capability to like a level 4 plus autonomous agent. What's your thought on these AI agents? Because these AI agents, the more autonomy you give them, it's gonna get more intelligent. I mean, do you think that eventually maybe these AI agents could be a pathway to building artificial general intelligence?
Sure. Yeah. So let me talk about the levels of autonomy or levels of agency first. And the article that you mentioned, so it was triggered by the world, the technology world shifting and trying to now talk about agents and envision what agents and our agent tech future would look like. So before, I think 2023, agents and agent tech research was part of academia. And I don't think people outside of academia thought as much about agents, but with the arrival of ChatGPT, Claude, and all these other conversational technologies, now the world has started to talk about agents and agent technology in general. And I wrote an article in response, or like to try to summarize where we are at in terms of how complex agents are. right? So the simplest agent you can imagine, this would be like a level 0 agent, is that you have programmed this agent to do something. So I don't know if you're familiar with robots like Roomba that try to clean your home. So you press a button, they have a predetermined process that they follow, and then they would go ahead and clean the room. So this would be like level G0 agency or level 0 autonomy, because these are agents that are pre-programmed to do certain behaviors, and once you press a button, they can do it, right? So this is the simplest version of agent. It's basically a program that has been written down. And if you write a program in a general enough fashion, it can clean most homes. The level 1 agency or autonomy would be when you can instruct the agent to do something as a step of the task. So for example, I don't know how, if you have been using or your audience have been using the recent agents that GPT is releasing. So you can, like, for your computer agents, you can say, okay, move my file from this location to this other location. So you can provide an instruction in natural language, and it can go ahead and execute that instruction on your computer. So this is what we can call a level 1 agent. So that agent's job is to not think about tasks. It's not to think about what the goal of the task is, how you want to execute the task, but it's to just execute what you are telling it. And so it can go ahead and do it. So that's level 1. Level 2, some agent could be something that you can describe an outcome to, and it figures out how to get to that outcome by itself. So this could be something like you ask a robot or a computer agent to say, hey, I want you to organize my files in directories based on their content, and I want you to do them alphabetically. So you have described the outcomes that you want to achieve, but you are not telling it step-by-step instruction on how to do that task, right? So level 1 was you were telling it step-by-step. It didn't care about what outcome you want to achieve. Now it actually has an understanding of an outcome, and it can plan a sequence of actions by itself that it knows will achieve the outcome. So that would be level 2 autonomy. Level 3 is something, an agent that can actually learn from you. So in some cases, when we start building agents, agent designers can program certain behaviors in the agent or train them to do a set of things, right? But what if you wanted to do something very different, right? So what if you said, I want you to organize the files by their content, but it didn't understand what that is, right? Like organizing files by their content. So it can ask you questions. It can say, hey, okay, so how do I understand what content is in your file? So you can say, okay, my writing files have, 3 different topics. I write about agents, I write about economy, and I write about, history of the world. So you look at each file, categorize what subject it's talking about, and then build me 3. So you describe to it parts of your task that it may not know about, and it learns from that. So the next time you give it an instruction, it's able to do it. This is level 3 autonomy. Let me pause here and see if this increasing autonomy or agency argument makes sense for you.
Completely. So I think, I mean, my first question would be like, I mean, where are we at this point in time
Yeah,
in
yeah,
the
that's a
stack?
great question. So, yeah, let me just complete maybe very briefly the rest of the levels, and then we talk about where we are. So level 4 agents are like from level 4, so until level 3, we are assuming that most of the expertise of thinking about the task and the world actually lies in the human hands. And human is providing information and knowledge for the agent, and the agent is mostly in charge of executing it as being specified. From level 4 onwards, we can shift the burden of expertise towards the agent. So we can start with saying more of a partnership. So for example, what if you are a computer user who doesn't know how computers actually function? So the agents can actually help you. That would be level 4. Level 5 and 6 are actually agents teaching you how to use a computer. So this would be, I don't know, I go have fond memories of my Nana ji, who would come in every day and ask me to teach him how to like use the computer. And so you can think of as agent that actually helps someone learn how to think about file organization in computers, how to think about browsers, how to think about safety, security, and things like that by itself. And then we have level 6 plus, which is when the agent also doesn't have any expertise, the human doesn't have expertise, and now this pair has to learn itself, right? Like humans can and become more autonomous in their learning. Excuse me. So as we see that these levels of agency or autonomy that I'm describing, they are mostly about where does the task expertise lie between in the human agent pair. Currently, we are at so level zero is actually products in the market, right? Like there are a few different. So that's a solved problem. Level one is where we are currently building the Agentic AI stack right now. So OpenAI, Claude, they all have their agentic frameworks that are coming out, and they allow you to build level one pretty robustly. And we have some cool examples of level two autonomy, which is level one was if I give it an instruction, it can follow it. So computer agents exist and you can go use them. Coding agents exist, you can go use them. So they are all executing level one autonomy. Level two autonomy is like, you can say it's like between the research and the science. So it's almost there. I think in the next few years, we will see level two autonomy that people can describe an outcome. The agent mostly can do the task, right? So I think we'll get there. Level three onwards are currently in the science technical realm that we are still not sure if our stack has the right components in it to actually build level three onwards. And a lot of the work that I'm doing and my colleagues are doing and other parts of AI are doing is try to push this forward. So yeah. But then I think those would be more challenging because the current agent tech stack is built upon neural networks as a technology. And it has some strengths and some weaknesses. So we are not sure if we can get to level three with what is currently part of your technical stack right now. So it could be that the stack has to expand before we can build these other kinds of agents. You asked a very interesting question towards the end, which was that will they become fully autonomous and just take over the world, I think. And I think the answer to that, it's an interesting hypothetical because I mean, I still haven't seen. So, to become very fully autonomous, you have to become autonomous in learning, right? So, humans have great autonomy in learning. Like, if, through this conversation, you and I are going to learn a whole lot, right? So, and all of that is driven by ourselves. So to build autonomous, not autonomous agents, but autonomously learning agents, it's the holy grail. And we still don't have great methods. The science isn't there yet. We don't understand how humans do it so well and how are humans so resilient and robust in our environments. The science isn't there yet. So it's a really exciting science project. And I think if you asked any faculty and any AI scientist, I think that's what they would describe that they're wanting to build, right? I think the other question is just of a design question. Like I think of AI agents as normal technology. So there's this really great faculty, Arvind Narayan from Princeton University, who has made this argument that instead of hyping up AI as something that would take over the world or just dooming it and saying this is pointless, I think we should think of it as just totally normal technology. We, as a species, gets to decide what's important to us and what's useful to us, and we build those machines because it helps us in certain ways, and we don't build the other ones that do not serve our purpose. So and that's how I think about it. These are computational algorithms. We design it for specific use cases, and we design it for cases where either there's not sufficient human capacity and you want agents to help humans increase the impact that they're trying to have. And in those cases, it's a really great deployment. And you think through problems as you approach those problems with agentic solutions, and you build them for those very specific purposes. Yeah.
Right. Yeah. So Shivali, you mentioned that currently we have these level two AI agents, and we are at the cusp of possibly developing a level three, and then maybe going beyond if you kind of tinker around with maybe like new tech stack altogether rather than these current statistical models. Because yes, I think there are globally, I think there's so many frontier AI research scientists who are kind of tinkering around with not just specifically large language models, the statistical data and data out models, but other approaches just such as neuro AI, neuro-symbolic AI. There's so many others who are kind of working on different kind of approaches to kind of see and push, like figure out like what could we do to kind of maybe build these self-learning tools. And I'm sure that's the holy grail, and eventually hopefully we should get there. And you rightfully pointed out, I think there are the boomers and the doomers. I think maybe the middle path is somewhere which is possibly the right approach, but I think that largely it goes towards the doom scenario, because I think the media paints it as like a very existential threat, because largely because we live in a capitalistic world, and somehow most of these AI companies are all centralized. eventually, even if they kind of build they build machines which have general purpose capabilities, it's very unclear whether the benefit is going to be distributed, or it's going to be like centralized, one power, I mean, kind of running over everything. So possibly, maybe that's the concern of like a layman and a common person. And I think, and largely also because these leaders such as Jeffrey Hinton, known as the godfather of AI, they and many others who also say that largely in these AI tools, they still are black boxes, and we don't really understand what's going on uh, under the hood, those large matrix multiplication. So I think those are these combined maybe concerns for these AI agents. I mean, we will try and get into like possibly what we might require to like the push beyond build like level 3 and beyond agents. But what's the current stack? When you say about building an AI agent, what's the process of building an AI agent? Because earlier I think was like people were accessing large language models, but then recently I think there was a breakthrough paper by NVIDIA, and which says the paper's title is "Small Language Models Are the Future of Agentic AI." Would love your thoughts on like how do you go about building AI agents, and the thoughts on this like small languages, which is possibly pitching it as the future of AI.
The stack question is really good. It's currently still evolving. So at the base, you can think of it as compute hardware that you have, right? So that would be your classical CPUs and GPUs, or which the computation happens. So GPUs, you do multiplication, large matrix multiplication, but CPUs are ones that are also running, your typical program. So that's your basic hardware layer. Above that hardware layer exists what can be understood as the inference layer. These are the large models, right? So they are so an inference layer computation would be that you give it a question, it uses whatever its training is, however it's designed to then produce an answer, and then it will take the next question and produce an answer. That's the inference layer. That's where we have most of the foundation models like GPT, Claude, some, and this is where the small models will also lie. So large models are designed to handle almost any arbitrary question that may be asked by anyone on the internet. Small models are carefully distilled to either do some specific tasks or try to have a large model's capacity in a much smaller model that can fit within your own computer, right? So the model parameters are not enough. You can actually have your own computer and have your small model running in it. Currently, the large models run over GPU clusters. So I don't remember this specific NVIDIA article that you're talking about, but the reason NVIDIA and actually Microsoft and Apple are all excited about small models is because of this rising concerns about privacy, where if, say, you are in hospital and you want to build an AI solution, you don't really want your patient's data being transmitted over internet to a large model company, which can train the data, and then it violates a lot of compliance issues across countries, right? So if there are small models that can run on your local compute cluster and don't need to hit the larger models, then you can guarantee that kind of privacy, right? So that's why there's a lot of excitement on it. And I think small models will play a large role in our agentic and AI future. But I think the large models are critical to build small models, because the way you usually build small models is you have the large model teach the small model, right? The large model, through very complex computation, has figured out the right way of arranging things, and now you can use that to build a small model. So that's your basic inference layer. Now, on top of that is a new kind of layer that's still currently being built, is an orchestration layer. So this is, like I said, right, like that inference layer is you ask it a question, it gives you an answer. But remember, like when I described an agent, the agent has to take multiple decisions as it's pursuing the task. So that means it has to ask multiple questions. So what the orchestration layer does is it takes a task, breaks it down into multiple problem solving steps, and then says, okay, to find this answer, I have to go ask my language model. To find this answer, I may have to call an API, like in my calendar API or weather API. To find this answer, maybe I have to go to a calculator. And then it combines all of these processes together, the answers of all of these processes together, to then produce, the task behavior that you want. So this is the orchestration layer, and this would be something like LangChain or LangGraph or Crew AI. And I think OpenAI may have their own agent orchestration library. So that lies on top of the inference layer. And over that is the agentic AI applications that are being built. So these would be the agents that you actually see today. So yeah, so this is what the current stack is. Now the question is, level one seems to function, even though there are still trust issues here, right? Because the base inference layer that you have is not a deterministic inference system like a software program, but it's a probabilistic inference system that, has, it will mostly do the right thing, but then there's certain probability it may not do what is being expected. And because of that, as you chain all these problem solving steps together, you might actually walk down a path that doesn't do your task or does it very differently than you expect. So level one almost sort of done, but there's still some trust issues. Level two, I think we'll get there. What is not clear is that if the stack is sufficient to get us level three and onward, right? Like if the inference layer that currently exists, will it get us there? Will the small models be sufficient to get us there? And that is where I think, and personally, my own research interest and my excitement lie, is that how do we expand that inference layer to bring other inference components that we know function well, and then build orchestration on top? So that's what I'm working on, and I'm the most excited to advance the technology.
Will be great if you could talk about that. I mean, what do you think is needed right now to kind of push beyond and maybe go towards building level three agents? What's the biggest challenges you're encountering over there? And maybe also talk about this, because I think you already kind of gave us a glimpse about how do you orchestrate these multi agents to gather and possibly use maybe MCP or something like to bring in these tools. What's your intuit over there? How do you get these agents to kind of perform effectively, especially in these open unpredictable environments?
Yeah. It's really challenging. I think like a lot of the demos that you see are very carefully set up to demonstrate the strengths of it. And it's challenging to like fully handle a very open, noisy world, which is why I continue to be amazed by human cognition because we handle that beautifully. Okay. So like how do we get to level three? So when I started in graduate school, my thesis is actually building level three agents. So there is some example proof of concept that exists in the world that studies level three. So these are level three is when the agent post its training may not be complete for your own use case, right? So this is something like I described in your computer agent. It may not know what does it mean to organize files by content because that's not something it has been trained to do. So how can you as the user or the human working with the agent teach the agent the right components so that it can do that task reliably from now on, right? Like that's the question that you would have to answer to build level three. So um, I think there are a few different things that are needed to. So I'll talk about the problems first, and then what does our tool set of AI provide to solve that problem, right? So the first is that the agent must be able to recognize own competency, right? So the agent has to be able to say, okay, I can do these parts of the task. I can divide this task into these four steps. I know how to do step number one, three, and four, but step two is something I do not know. So it needs to be able to recognize that so that it can ask you that question, right? It needs to ask you, hey, I do not know how to organize files, right? What do you mean organizing files by content, right? So this is where the current technology starts showing its limitations. The way the current tech works, the inference, the neural network inference, if it doesn't know the answer, it can still hallucinate in that direction and fill up the gap by itself. So it's very hard to detect when the agent actually doesn't know something because and this is one of the strengths of neural networks that it can fill up all the gaps. But in this level three case, you actually need to recognize and highlight the gap because that's how you learn. So this is where I think it starts hitting boundaries. So that's the first problem that the agent needs to solve. The second is to learn from really small but very specialized, unique data, right? So you, as a user of that agent, is unable to provide it like thousands of examples of that task performance, right? So you can only provide it maybe with definitions, some structure, and maybe demonstrate it once, right? But that's like a very classically a very small data set that it can get access to, and it has to learn a lot from that. So right, so we have to move. So it has to somehow, in its large training, integrate the small data that's coming in very cohesively so that it can fix it. This part is very challenging. And then the third is like to manage this human agent interaction really well. because you have to ask the right questions, you have to figure out how the answer fits into what you know, and where the answer doesn't really fit, and then you have to go back and ask. So you have to manage this interaction really well as well. And humans have very specific expectations about interactions, right? Like, we talk to each other all day, and that leads to us building some very specific expectations from the conversations we have. So you have to align the agents to match those expectations as well. So this is what we would call human-centered design, right? Like, you have to really think about how humans teach tasks and then absorb them. And this teaching is very different from like the training that happens, right? Like, this is actually live teaching that we have to do. So we have to solve at least these three question problems, at least, if we have to solve level three. And this is where we start hitting the bounds of what can be done with neural technology. Because, like I said, already said that it's hard to detect when it doesn't know something. You can not find a single, like, conversational agent that can say, I don't know. It will always invent, and it can be creative with the answer, but it will never say, I don't know. The second part is this online learning, which is you have to do this learning live, right? And then and there, because the neural network paradigm is based on large data, based on these large matrix mathematics, it learns the entire knowledge as diffuse patterns in its weights. It's really hard to then figure out how do we integrate now the small thing that was told by the human into the system. And so you would have to build the right memories outside of this inference system, and you would have to build other computational techniques to solve that. And then the third is this human centered design piece, which is that we still don't know how to build this natural interactive system. Like, yeah, people can learn how to write prompts, but as systems get more and more complex, the prompts also get more and more sophisticated, and then you have to learn a lot. So it's not then in natural interaction, it's actually quite constrained. And we want to move technology to actually talk like you and I are talking. And so what will get us there? Like, those questions are still being researched and talked about.
And I hope that we come close to that and hopefully are able to sort. And I mean, we want to build these agents, which have perception like us, memory. It learns like us. It's got like a reasoning, and it's able to plan and act in the open world. But till today's model, they hallucinate. They still a black box. There's so many problems. But hopefully, I mean, we should be able to like overcome those problems and possibly build maybe level three agents and beyond. Today, there are companies, such as Google, which has built this AI co-scientist, and the Sakana AI, which is again build these AI scientists, co-scientists. Can you explain to us what are these AI co-scientists, and what are its actual capabilities? Do you think that eventually these AI co-scientists would make original research breakthroughs, using first principle thinking?
So I think, I'll talk about the positives and the negatives about both, and maybe like the job of an AI scientist. So job of an AI scientist is actually, or scientists in general. I don't think that we are always working on really novel breakthroughs. Different types of scientists have different things that excite them, right? So, like the theoretical physicists that I know about, they may be like, okay, what does humanity not know and how can we discover that? They might be working on that. But someone like me who is working on more the applied science side of things, my excitement is that we know we have this finding from the academic literature. How do we build a new technology based on that? Right. So I wouldn't. So what I do is also novel, and what the scientists, the theoretical physicists doing is also novel. But then they're applying very different kinds of reasoning techniques to solve each of those problems. So when we are thinking about AI scientists, I think that's how we have to think about is like, what are the different kinds of reasoning techniques, intelligence that scientists have learned through their experience that they're applying for their work. And I think like that understanding is also not fully clear yet. So from what I understand, I don't know about the Google scientist copilot specifically, but some of the other AI scientist papers that I have read, that they're trained on other scientific findings papers, and then they can combine the technology that's been described in them in different ways to maybe get to a new different finding. Now, if that like the scientific process is not just about getting to a new finding, it's also to argue, is that finding important and relevant? Like, does it move the field forward or in a different direction? Is this useful? And all of those arguments, I don't think those arguments can be very well made with the current AI tech right now. I think Google has built some very cool systems that can help scientists do good jobs. I wouldn't call those systems AI scientists themselves, but their recent Alpha Evolve system can figure out new ways to write code that has certain properties that a human has described, right? So if I think about like building up a new system and programming up a new system, I may have some idea of what I want the properties of the code to be, but then to actually figure out, write all versions of the code and then see if it satisfies my properties is a very challenging task. I might try a few different designs and pick one, right? So I cannot really search the space very efficiently just because I'm limited by my own cognition. Now, what they have built is this really cool system that can search the space for me based on the guidance that I provide. And I think that's a very useful tool. So that's how I think of all these scientific AI scientific tools that are being built. I think they would provide scientists with a lot of ways to explore the space of scientific ideation really, really efficiently and very, very well, which means that we can get to solutions much faster with those tools, or we get to solutions that we might not have been able to get without those tools. I think that's been true with a lot of Google's research that happened at DeepMind with the protein folding and other things. Like they definitely built tools that are now have tremendous scientific value and being used by scientists every day. I think like a fully autonomous scientist that has this very intuitive finding, that very like finding that no one else in the history in the scientific world knows about, I would be very surprised if that happened. But then again, like I've been surprised in the past 5 years a whole lot. So I don't know. And I think it's also like it's hard to predict the future because we still don't understand, as you said, these machines sufficiently. But I think it would be a surprising thing for sure. And there would be a lot of excitement around it being able to do that. But I don't think that should be the purpose of designing these co-scientists and these tools. These are designed to make scientists' jobs more efficient, easier, effective, and things like that. And that's what I believe in. And I think the AI role, the role of AI systems, agentic systems, is to make our lives easier, make our lives healthier, our lives more sustainable. That allow us to follow curiosity and all the properties that humans are innately wired to pursue, and not to automate our things away. But I mean, I think different people have different perspectives on how to build AI.
Shivali, I'm completely with you that we need to understand truly what we are building, because I think the conversation, Shivali, going out is that these tools are accelerating the capabilities of what it very very fast. And the narrative that's going out is that eventually it's going to automate everything that we do, like every single job. And so that becomes like a concern to like a larger population, which would be like a fair I mean a concern by the larger population. And I think that's where we are, because like there is like I mean, when I don't read AI papers because I'm not an AI researcher or scientist, but every day there is like a growing number of AI research and papers, coming out. And it's very overwhelming. And it's not just these AI research and papers which are coming. It's these models, people are building around the world, right from individual research or institutions to these well-funded, large big tech companies. So it gets very, very scary that, what the future holds, where eventually if these agents are going to become more autonomous, because these agents today can code, can build images, can design, and can do quite a lot of things. And eventually, like you said, I mean, the way you kind of gave out the future about your the map of AI agents, the level zero agent to like level six agent, and currently said that we are at just the cusp of kind of figuring out level three. So eventually, I mean, when you say that we are at the cusp of figuring out level three, that means the work, research, and understanding is going towards three, and eventually, obviously, beyond. Because I guess we humans are these curious creatures, and we are always trying to build things which is beyond, and I don't see us stopping. And I sometimes think that that's great, because I guess that always will be the case, because as scientists, as researchers, as artists, we are always trying to create something which is better than what we did last time around. And that's it's not going to stop, so I sometimes feel that what will happen eventually, if we are kind of creating tools which will eventually, if maybe automate every little thing, what would be left for us humans? So that's like a thought which is there. I mean, is there something that you kind of think about, because you mentioned that it's level 3, or is something that we are looking at. Eventually it's going to be level 4, which is going to be self learning, and beyond that it sounds like not just AGI, it goes to super intelligence and beyond. It seems like God, I mean, what would be that world? So do you think about that? Does it kind of worry you?
And I think it also drives a lot of the ethics of like ethical decisions that I want to make on my own scientific work. So you are right. Like humans are very curious species that we are constantly like we pursue curiosity so much that we have changed the world for the good or the bad is for the discussion for maybe a different conversation. But we have changed the world. We have changed even like our planetary system, right? Like we have put satellites in there and we have made dents in how the universe exists. So even in the space of AI, I think we'll continue to pursue. I think there are two jobs. Like I think it's the job of AI scientists to explain what AI systems can and cannot do right now to the truest form, like to our truest beliefs, like what we know about it, to the general public, to the governance, to the civil rights groups, to everybody, and explore what can be done with them. Basically, it's like to try to fill that knowledge gap as much as we can instead of keeping that knowledge trapped into like the ivory tower of AI right now. So that's on AI scientists, and then help shape the social and the society and the policy and participate in those discussions. So in the US, for example, now there are multiple lawsuits on how AI should be governed and how AI policy should be made. And I think it's part of like the AI scientist role is to help inform those decisions so that we are building AI in the right direction. So I truly believe that agents can really help the world, but we have to be really honest in designing agents that are helpful. Right. So like my sister is a surgeon in India, and she for several years worked with the rural population in Bihar. And she talked about this really interesting problem where a doctor, so she was working in the maternity field, and she said like a doctor who's taking care of pregnant women, they have like 4 to 5 seconds per woman in like a district hospital to then figure out if this woman needs more medical support, right? This decision is really hard for doctors, and just women just don't get enough time with the doctor. So here you can actually have agents expand the human capacity, right? Because agents can actually interact with women and their caregivers to then triage women in order of severity and then make sure that the doctor's time is devoted most to women who need it the most. Now, this, I truly believe that if we built AI technology for this problem, this would really help because we don't have humans who are doing that task right now. And if there were more humans doing it, we would have better medical systems, right? So, personally, for me as an AI scientist, I'm figuring out ways on how I find problems that I want to work building, but that I want to work upon and build agents for them. And then how do I sort of solve the pragmatics of solving that problem, right? Like it's the AI work is not just I solve that problem, but it's also like where would the compute come from? How would the customers of the space operate? Who's the actual customer? Is it the government and things like that? So there's a lot of pragmatics that is involved before you are able to build a software system. But I think we have to be very, as AI scientists, have to really think through what is it that we are building for. And personally, for me, it is finding problems that truly, with an agentic solution, expands human capacity as opposed to automating the doctor away. I think those are two different viewpoints that you can have. Like, I could be saying, oh, I just want doctors don't do a great job and I want to automate them away. I think that's a very slippery slope and a trap that I think we should try to stay away from because I do not want to live in a world which is run fully by agents. I don't think that would be a great world. I don't think I would enjoy in that. But I do think that agents can expand human capacity. So we have to think of agents in AI as human capacity. And actually, I'm very inspired by work of Milind Tambe, who's a phenomenal scientist. He is He was born and brought up in India. He now is a faculty at Harvard. I have had a few conversations with him, and I've been following his work. And I'm just very inspired by this very thoughtful approach he has about his own research. And he's currently working in Indian spaces, in the actually Indian medical spaces for Indian women. So I think you have to be that judicious. Like AI scientists have to be that judicious in figuring out like what is it that we are building for. And unfortunately, it's really challenging to be that judicious right now because of the money that comes in into the AI field in general, the investments. But I think as a society of scientists, we have to communicate. We have to like talk about how we decide what problems to work on. The second part is on the civil society, like people like yourself, is to like ask these really hard questions of why are we building systems that automate, that are generating this, or like these agents that are writing news articles that we have no idea if they're correct or not, and they're polluting our information space. Like right now, even my own things, if I do a Google search, most pages that I reach to are all Gen AI generated. So I don't know if I want to trust them or not. And so it has already spoiled our information space. And so this is, I think, like, again, like as private citizen, we have to work with our governments. It's like, what is the legislation around it? Because frankly, this legislation just don't exist. Even though the agents are not good enough to write a really good report, they still are being used and they still have made things worse. So we have to figure out like how much evidence these companies have to provide us before we say, okay, this is a good agent for our use cases and it should be allowed in public, right? Like those kinds of decisions the government still have to make, but that requires like the public citizenry, the government to all get like figure out some expertise in AI to be able to legislate that. But I think that's where it will get to. And we have to ask those hard questions of technology in general and not just AI, right? Like even with social media, it's not clear if it is having a net positive impact or net negative impact and what parts of it are positive and what parts are negative. But those are hard questions I think we as the human species needs to have, because just purely going by the incentives that currently exist, I don't think we'll just luck upon a future where agents are expanding human capacity. I think a lot of the times agents would automate the tasks that humans are doing, but at such so poorly that our world will get much worse before it gets better. And we don't really want to go through that. But yeah, I just don't know if like the purely capitalist incentives would get us to the future that we should try to build with this technology. I don't think like with purely capitalist incentives, it would like figure out an AGI that rules the world. I know Jeff Hinton has said that, and who am I to be critical of Jeff Hinton? I think he's a phenomenal scientist and like inspiration for all of us to like how to pursue an idea dog-headedly. But yeah, I don't. I can say that I personally I don't want to live in that future. I don't want an AGI, and so I'm trying really hard to figure out how we not get to that future, but get to the future that I'm describing, which is that women get the healthcare that they deserve and they require.
Yeah, Shivali, I really truly hope and I wish that we get into a world which is the picture that you painted rather than the dystopian world, because unfortunately we live in a top down hierarchical capitalistic world, and it's the powers that be, create the tools. I think, there is no good or bad. I think there's a middle part which is always good. Like, for example, you spoke about the internet, the web. It's largely painted as something, which is kind of destroying or youth. But I think, internet itself is such a beautiful thing. Because of internet, I think we the entire world is a friend. We can reach out to each other. But the only problem is, as humans, we don't really know where to stop, and we don't understand the middle path. And the powers that be, like the people of these tech companies, they've kind of figured that out. Okay, how to kind of manipulate, and they know that attention is the key. And that's where the money is. That's the reason these platforms are basically free, but they catching all your attention. We are like digital drug addicts of sorts, because we cannot live without our phones or our computers. So I hope that we get into a world, the future, where there are these AI agents who augment us. They don't automate us, they augment us, and they make us understand our place in a world. And we build tools which is more distributed rather than which is unequal, because there's right now, you want education or healthcare. It's only for the privileged few, because they are the ones who get the best education or the best healthcare. I wish that, it's more, it's equal for everyone, but that also seems like an idealistic picture. I don't really know whether that is something,
No, I think
which
it's
can.
a, yeah, I don't think it's like super idealistic. I think for any developed society, you like it's developed because you can guarantee some basic level of healthcare access, education access, access to other resources. And so as we move towards that, like we have to figure out new ways of guaranteeing that, right? So if agents can come in and help, like you brought up education, and I think that's where a lot of effort can go in and help. Like I think Indian students, for example, are one of the most industrious, I think, in the students that I have seen. Like, I know that Indian universities aren't that great. You don't get to learn a whole lot. But Indian students, I think they're just next level because of like access to Coursera and all these other learning platforms. I think we have trained ourselves, like students have trained themselves to learn so many new things. And so, like, there's this innate desire to learn, and agents can actually help design your coursework for you and work with you to actually learn things much faster, much deeper. And that would create more equity in the education space for sure. So I think we have to like keep those problems centered as we talk about AI, right? Like instead of getting totally sad about like, oh, AGI will come and it will rule us. I think we should ask, like you should ask, and others citizens should ask the AI scientists, like, hey, what are you doing in education? What are your approach in that? Like, how are you building? How are you considering? Ask the policymakers for that. Right? Because unless there is a push to say, hey, we want to solve this specific problem, it's very hard to then get the whole capitalist system flowing in that direction. So you have to create incentives. And I think with government and policy, we can create those incentives and we can push the society to move in that direction. And if agents are a way to ask, like, to guarantee certain access to like healthcare and education, I think that would be phenomenal. That's a world I definitely want to live in. And like in any tech, the problem cannot be solved unless like we have multiple iterations with that, right? So this cannot happen. So if we are just continuously chasing this mythical AGI, which we have not really thought how it fits in the education space, I don't think magically we'll get a solution for the education problem. Like that just would not happen. The AGI would do something that's destructive in a completely different way. So I think we have to create that push. Internally, AI scientists have to create that push, and externally, I think the citizen of the world have to ask these questions, work with the governments to make sure that the fruits of AI is actually accessible to all. I don't know what to do about the large tech situation. I think it is right that I mean, there are two solutions to it. One is that currently, like one is just driven by the technology pieces at themselves. Like I talked about, like to run a large network, you need larger resources, but with small language models, for example. And then for other symbolic reasoning techniques, they all can run on your computer. So you actually don't need that large infrastructure. So if through research we are able to figure out how to get to agentic AI that's not completely reliant on language models, but actually also can use symbolic computation very easily, I think that would break the AI out of its prison, and then everyone can hopefully run an AI. The second part is just that how the AI is being structured. So the US is a really good example, and I think EU also, where the governments there are sponsoring building these large models themselves. So National Science Foundation in the US is building a government supported language model, and then so is EU. I don't know if India is doing the same thing as well, but India certainly has the resources to do it. So I think the government should also build like a competing infrastructure, which will then equalize some of this race to, I don't know where, but race to AGI, I guess. But
Is it's not just these biggies, but even the governments kind of understand that, when you acquire these potent tools, it gives you an undue advantage over the others, and that's what's happening. I mean,
yeah,
I think all
I see you
nations,
saying that it would, yeah.
all big companies are just racing towards building these AI tools without, like, I mean, possibly thinking, asking these larger question. Now, you've done some work on your integrated AI system, Rosie, where you combined natural language, vision, and action in one interactive learning model. Will be great if you could talk about that, and maybe also could talk about agentic AI applications and something. that's like really caught your attention, when these agentic AIs?
So yeah, let me talk about Rosie first. Rosie, I mean, few things to know about Rosie. It was built when AI was not what we currently know of AI. Like, so this was built before 2014, before we had gone through this revolution in AI. So the way to think about AI as a field is that there are two different competing philosophies of what is intelligence. So one is what's popular right now. So that's the statistical way of thinking about intelligence, which is that we can learn these generalizable patterns from large data sets, which are then useful for us to make decisions. And neural networks are a machinery that allows us to do that. And that's the statistical view. But then there was this other view of AI, which was more cognitive, which was that, hey, let's understand why humans are so intelligent. And through that pursuit, there's some strong evidence that humans are symbolic reasoning machine. So instead of manipulating data and statistics, we are actually manipulating symbols that are connected to things that we're observing in the world. And so basically those symbols are a way to represent the world that exists out very simply and very efficiently within our own heads. And we can run simulations with those symbolic models, which then allow us to make good decisions, right? So there's this cognitive philosophy of AI, which used to be really very popular in the 80s, 90s, and the 2000s. But then because we have had wins from that philosophy, and then now the AI technology has moved, right? Like the wins from that philosophy were like things like Google Maps, which now everybody uses, and it's actually designed on like a symbolic search algorithm. And it's so powerful that everybody uses it. And in fact, like even the robot that we sent to Mars is largely a very symbolic reasoning machine. So I find that absolutely fascinating that we built this machine on Earth. We sent it to a different planet and it's operating there and it's sending us data that's helping us learn more about that planet when we have never not visited that planet. So humans have never been there. We have not collected that data, but we were still able to build a machine that's operational there and it can work there. So that to me is like phenomenal. And symbolic reasoning was the way we got there, right? So we have had some very prominent wins, which we are currently don't talk about it as the AI umbrella. But there is this very healthy sort of legacy of AI research and symbolic systems. So when I talk about Rosie, that's what it was built upon. It was built upon symbolic reasoning, logical inference systems. And it had all these different components. It had computer vision, although it was very, compared to vision that exists today, it was very minimal and hacked together. But it had vision, it had action reasoning, it had learning, it had human agent interaction, and all of those pieces that we would imagine a level 3 autonomous agent to have. And we demonstrated that it actually can learn through small data. It can have this in meaningful interaction with a human and can learn new tasks. And actually, there is a very cool paper by my colleague James Kirk who showed that it can actually learn 50 tabletop games just through interaction. So it was not pre-trained to solve any games, but by talking to a human and human teaching it the rules of the game, it can learn to play. I think that was a phenomenal research direction. And the reason why we were able to learn from small data was this very smart, judicious use of symbolic representation and symbolic reasoning techniques. Because if you figure out the right symbols, working with them is just very, very efficient. It can happen on computers, it can learn really fast. But the challenge is that to generalize that learning to unseen scenarios, because symbols are very, they're like discrete descriptions of the world, right? They're not evolving, they don't change. So, which means that if the world changed, then the symbolic system that you had originally learned may not really fit into the world. So a lot of the work has to be done in figuring out how to make the symbolic reasoning operate in an open world. What does symbolic learning really mean? I think, unfortunately, for the AI science, all of the energy has moved into the statistical view of the world, which I feel like is bad as science, because if we all are studying this one small part of the frontier, what if the solution actually lies in some other part of that is scientific frontier? Or what if the solution is actually a combination of that? We won't be able to get there. But I think, like, with now some recent reports that have come out on how LLM based technology is functioning in the business world, there is some pushback on, like, we are not getting that reliability that we need. We don't get explainability and trust in the computations, which symbolic systems very naturally provide, which is why you are now starting to see a push towards neuro-symbolic AI, which is that how do we handle the openness of the world through neural systems, but how do we get to like guaranteed trustable behavior that can be understood by using symbolic AI? And so now the technical question is, how do you merge to these two different, very different philosophies of thinking about the world? And that part is just not clear yet, but it's very exciting because that's what I want to study and I have been studying. But it's I think one of the things that you'd hear more and more about is like a neurosymbolic system.
In fact, Burp and Gertzel, I mean, I think is researching on neurosymbolic, and that's the approach that they're taking into building decentralized AI. And I hope that we go more towards that, where then AI would be explainable and also decentralized. Shivali, I mean, obviously, when you're talking about building these AI agents, you have these AI tooling platforms like Crew AI, AutoGen, LangGraph, but these require like a certain expertise in coding, and there's a lot of my audience, who know nothing about coding, so for the ones who don't know coding, what are those tools over there like HubSpot, Zapier, Lovable, and what do you think, I mean, we can actually build on these no code tools?
Yeah, I unfortunately don't have a lot of experience with no code tools because I love to code, but I certainly understand the challenge. I think what I would say, like GPT and its ilk have done, I think has made coding much more accessible than it was originally. And the work continues to happen in that direction. So I think like using GPT to learn how to write code, I mean, it can explain the code really well. It can help you learn it. So if that's where the interest is, I think you can use that tool. The no code platforms are interesting as well, and they've always been part of the programming world, right? Like even before the AI revolution came along, there were like more graphical user interface based coding methods that people visual ones, and now there are language ones. I think these are really good tools to try and learn programming. I think it's challenging to build very complex systems with just no code tools, especially the language ones, because natural language is by design very ambiguous, right? So when you and I talk, the words that we use can mean so many different things. And we actually use the context from our world, our own understanding, and the context of this conversation to constrain the meaning of what that word is and get to a very specific representation. A lot of the times we talk to each other to just negotiate the meaning, right? Translating natural language, which is inherently so ambiguous, into code, which is inherently so precise, is a very hard challenge, right? So I think the how these systems, like you can not use fully natural language to write code. I think you would still have to learn aspects of coding to be able to write the right prompt that will generate the code. So I think it's worthwhile to understand the computing paradigm, if not precisely the language that you use. And I think computing as a paradigm has become so basic in our world that I think people should learn it. It should be part of our schools, just like math and languages are, because it's just so well integrated in our like it's like our world now depends on computation. And I think more people understand how computation functions, the less they will be fearful of it, and the more they can ask like really hard questions, right? Like, so I think it's people should definitely use these tools to teach themselves the challenges of programming, and learn that. I think that's a really beautiful thing. And I love that these large models have made coding so accessible. I think this is, if I had to say, like there's so many negatives, right? Like I talked about that the information world has gotten much worse. I think the absolute positive is that a lot more people feel more confident with computing because of these tools. And I think that's a beautiful thing.
Exactly. It's such a beautiful thing, because just maybe like a couple of years back, I think 2022 is when GPT launched. And from that point till now, it's just a matter of few years. But I think the world has completely changed, and it's changed by these statistical models, these data in, data out models. And it's crazy to think that in such a short span of time, I mean, the things that a layperson can do, you don't need to be an engineer, you don't need to be an artist. You don't need to be a designer. You don't need to be a coder. You just need to spend some time and understand what's happening, and how do you understand the context of, I mean, creating these prompts. and the prompts are creating magic. You put in a prompt and you're getting images, you're getting a design, you're getting a code, you're getting a full app which can be deployed. And that's so wonderful, where these tool has created like a democratization of sorts. You don't need to go through the grind, and you can do it. And I hope that eventually that we go to a world where we can maybe do magic or interact with these models just through natural language. Yeah, what a world would that be? My last question to you, Shivali, will be great if you could paint a picture of the world you vision in the next 10 years. And you spoke about the article that you wrote on LinkedIn, uh, level 0 to level 4 plus, and then you said, okay, eventually it can go to 5 and 6, and so on and so forth. Maybe paint a picture. I mean, what do you see in the next 10 years? We're sitting in 2025 at this point of time. What does 2035 look to you? And how do you think the world is going to change with AI agents?
Yeah, I mean, I don't know how it's going to be changed, but I can certainly describe what I want it to be. And then maybe that would be a thought for your audience to think about. And then for me to also like take this up as a mission and actually try to execute on it. So what I want is an AI agent. Like you said, right? Like learning, I think, is so critical to the human experience. I think humans are phenomenal learners. We start with a baby with nothing in our brains almost, and we have such great tools for robust learning that we can learn almost anything in the world that we desire, right? Like students go through a journey and then we eventually become these scientists who are now trying to answer questions that humanity has not known the answers for. So learning is such an innately human property. I want to build agents, and I want agents that support this learning process to the best of their ability. That if a, eighth class student from Meerut in UP says that they want to build the system, the system that helps members of their community, they can learn using that agent and they can build that system with that agent. Like that's what my hope is for the future, is that anybody can use these agents, and there exists an agent to you for you to learn anything you want. So I, for example, would love to learn more about the mechanics of my car because I know nothing and I'm completely reliant on taking it to the shop. So I would love to learn how to like where how my car is, like the machines of my cars are organized, what is the relationship and all of that. If currently I have to do it, I would have to like watch a lot of YouTube videos, read a lot of manuals and all of that. Imagine if like I could wear a smart glass that can look at what I'm looking at and can, in my context, as I am trying to move through my car, try to repair it, it's actually giving me guidance right there and helping me learn about how to repair my own car. I think if we have agents like that that help us learn in the physical and the virtual worlds, I think our lives would be much better. It would democratize, like you said, education. It would democratize building. I think it supports a quality that I think all humans have and all humans really enjoy. So that's the future I want. Want agents that help us learn.
Right, right. Shivali, thank you for taking time and being part of the podcast. You spoke about smart glasses yesterday, MetaConnect 2025. Zuckerberg kind of, showed like a glimpse of what that future would be, where we have these smart glasses wearing. And there's this fantastic creator. His name is Kichi Matsuda. So I am vested in AR, VR, MR, and Kichi Matsuda is vested in augmented reality. And he's created this fantastic video. It's called AI Agents, the future, where people are wearing these head wearable devices, these glasses, and these glasses you have these multimodal agents, and you interact with these agents through the natural language, and whatever you want, it creates for you. I think what a beautiful world that would be, where we have agents with us, multiple of agents looking for all good, I mean, is able to, I mean, maybe correct us, if we are doing something wrong, guide us to through the world, whether it's economically or emotionally, or even intelligently, if we have these agents stack. Sorry, I'm saying, yeah, I think you're saying
Yeah.
something.
No. I completely am aligned with that future. And I want to highlight that to get to that future, we have to really invest in purposeful design of agents, right? So instead of thinking about how do we automate the designer or how do we automate the artist, we have to, as AI scientists and engineers, we have to think very specifically about what a human artist cannot do right now. And how would we support their cognition? How would we support their creativity? How would we support their thinking? And design agents for that component that humans cannot do. So it's a very different view of how we think about agents, not as automations of what humans are already doing, but like you said, as augmentations, understanding where human cognition is limited and what we cannot do. And designing for that so that an artist feels more empowered to create designs that they otherwise would not have been able to imagine. A designer can explore the design space much faster. So we have to it will come through a purposeful design of AI and not just through like this AI's automation perspective that's so dominant. But I completely agree with the view that you just described. I think that's the view I want to work towards.
Right. I wish we go towards that world. So thank you so much for taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, so guys, thank you, Shivali. Yeah, really
Yeah.
appreciate it.
Thank you, Eddie. Thank you for having me. I enjoyed it.